Grade 5, Unit 6 quick practices. So in this unit, students are going to work on their situation and solution equations for addition, subtraction, and multiplication and division, as well as some fluency about what we can predict with our answers. When we multiply with fractions or a fraction of a whole number or a fraction of a fraction or mixed numbers and mixed numbers, what can we predict about our answers? So we're going to talk about all of those in these quick practices and bring them to rehearsal so that students can build procedural fluency with them. So when you get to lessons 1 and 2, you'll see here that there's one color slide that's lavender. There's one that's this off color. Every color slide, remember, is a new day. So this would be lesson 1. This would be lesson 2. So let's take a look here at lesson 1. And we want students to read the equation with us. Boys and girls, read with me. And I find this extremely valuable no matter your grade, but especially in 5th grade, because we're still growing accustomed to how we read decimal numbers. And I don't think we read them enough. So let's read together. G plus 3 and 87/100 equals 9 and 4/10. Class, what's the total? Think about it. Class, 9 and 4/10. Let's see if we're right. Boys and girls, this is the situation equation. What's the solution equation? Think about it. Class, 9 and 4/10 minus 3 and 87/100 equals G. So we can either say 3 and 87/100 or 9 and 4/10 minus 3 and 87/100 equals G, or G equals 9 and 4/10 minus 3 and 87/100. The goal is that we get that variable by itself and that we're understanding that inverse operation. Some students may still struggle with how to find that inverse. In that case, my suggestion would be that we actually draw on the slide a math mountain. And then that way we can say, so where would these numbers, it's just a visual, like where do these numbers go on the math mountain? Because technically 9 and 4/10 would go here and 3 and 87/100 would go here. So if students are forgetting how to do the inverse, this will help them to see that I can do 9 and 4/10 minus 3 and 87/100, that'll equal G. So this, all of these numbers work together. So then we move to the next one. Boys and girls, read it with me. H minus 4 and 86/100 equals 5 and 2/10. Boys and girls, which of these is the total? Think about it. Class, H. Boys and girls, H is the total. And again, this is probably the most misunderstood part. Everyone wants to think the total is the answer, and that's not the case. Remember, which of those numbers would go on the math mountain at the top? The total is at the top. So therefore, H is the total. It's what we start with. We subtract from that number, and then we would get 5 and 2/10. So now you can see that I can do H minus 4 and 86/100 equals 5 and 2/10, or 4 and 86/100 plus 5 and 2/10 equals H, or H minus 5, right? You can see the relationship here. Again, that's what's helpful about the math mountain or the break apart drawing. So for you, you don't want to spend a bunch of time talking about that. You just might need to plant the visual so the students are remembering why H is the total. I guarantee you students are going to say 5 and 2/10. Boys and girls, this is the situation equation. What is the solution equation? Think about it. Class, H equals 5 and 2/10 plus 4 and 86/100. Are we right? We're right. Boys and girls, read it with me. And you would continue in this fashion. Then as you keep going, you're going to see, let's see if we move up here, you have more addition, subtraction, remembering where that total's at. You'd be using math mountains. Then you get down here to lessons 3 and 4, and you can see that now we've moved into multiplication division. Boys and girls, read it with me. S times 7 and 9/10 equals 3 and 95/100. Boys and girls, what is the total? Think about it. Class, 3 and 95/100. We're right. The product is the total, 3 and 95/100. Boys and girls, what's the solution equation? So for this one, you might decide that you have an area model or a rectangle sections model, and we think about where the numbers would go on this rectangle model. So in this case, we know that this is S, this is 7 and 9/10, and the area, which is the product, would be 3 and 95/100. Now, you don't have to plug in those numbers, but just that visual alone will help students to see, oh, so I could really do 3 and 95/100 divided by 7 and 9/10, and that would give me S. Boys and girls, let's keep going. Read it with me. 4 and 2/10 divided by t equals 16. Boys and girls, what's the product? Think about it. Class, 4 and 2/10. Let's see if we're right. Boys and girls, what is the solution equation? How do I get t by itself? Class, 16 times 4 and 2/10 equals t. Let's see if we're right. We are. So you'd go through that whole process, read it out loud, which of these numbers is the product, draw the visual if students need it, rewrite that equation or rethink that equation and restate it with the variable by itself. Lesson 5, you can see continues on. Now it's addition and subtraction again. Then you can see we go back to multiplication division. So you go back and forth to build some automaticity there. Then we start talking about what we can predict about the product or the unknown. Will the product be greater or less than or equal to 2? Read it with me. 1/3 times 2 equals P. Will this product be greater, less than, or equal to 2? Think about it. Class, less than. Why? And so when you do less than, you can just delete that top box. So let's try that again. We're going to delete that box and it says P is less than 2. So that's what we would want students to say. I just did less than, you can choose. But then the why doesn't have to be read word for word. This is just boys and girls, who can explain why? Like quickly, or turn and tell your partner why. And then we can rehearse it in front of the whole class. Boys and girls, we know that P will be less than 2 because we're taking 1/3 2 times, and 1/3 2 times is not even a whole number. So you can delete that y and you'll see an explanation there. Will the product P be greater or less than or equal to 1/3? Class, greater than. Why? Because we're taking 1/3 2 times. We're going to have 2 1/3, so it's going to be greater than 1/3. Boys and girls, read it with me. We go through another one. We talk about what the product will be, greater or less than, and then we'll go through our whys again. So we don't want to just call in one student each time. If you can turn this into a turn and talk, I really suggest that. If you can come up with a way that it can be a choral response, fantastic. But that why part is critical in students not just guessing like greater than, less than. It's, oh, and we know it's why, and we know why because, right? And then maybe you have partner talk or you just state it. You decide how you want to do that. Then you have the same thing with decimals. So notice you do fractions, then you do decimals. You'll continue that pattern. And now you can see you have whole numbers and a fraction, but you also reverse. So it's the fraction of the whole number and a fraction of a fraction. So 1/3 times 4/5. We can also say 1/3 of 4/5. So if students are still struggling with that language, you by all means could restate it multiple times in different ways. And again, is P going to be, or the product going to be greater or less than? And you start with one of the factors, then you ask the same question about the other factor. You'll continue to go, you'll get decimals multiplied by a fraction. You'll get mixed numbers are coming in here. So mixed numbers times a fraction. And again, there's no solving. We're just thinking about reasonability and what do we know is what do we know about what that answer can be. So again, every color is a different day. So by the time you get to lesson 7 through 11, 7 is going to be just these kind of lavender colors. Then you get the next color here for lesson 8, the green for lesson 9, so on and so forth. You can see how this will really help students build some automaticity with these really critical skills. Enjoy.